Hello guys, my name is Hafiz, and then today I want to show you what is addressing and what is routing.
What is addressing? Addressing is any logical or physical address that uniquely distinguishes a network node or device over a computer or telecommunication network. Today, I want to tell you what is IPv4 address. IPv4 address is a 32-bit address that uniquely and universally defines the connection of a device such as computer, router to the internet. So, let's move on to routing. What is routing? Routing is the process of selecting a path for traffic in a network or between or across multiple networks. That's all for introduction. Thank you.
Now, you understand what the topic about? Let's proceed to next topic.
Before going deeper into classful addressing, we first must know how a computer communicates with other devices. A computer communicates using Internet Protocol or IP address and send datagrams to other devices. A datagram is a unit of transfer associated with networking. However, every system has their own drawbacks. An IP datagram does not contain any network subnet mask information. Thus, it is difficult to know which hosts form a network. Because of these very reasons, this is where classful addressing becomes handy. It divides the entire IP address spaces into classes or special ranges. Moving on how to determine the class of IP address, firstly, we must refer to the first 4 bits of the first octet in the IP address. This is because the first 4 bits is the most significant bits of the first octet. It is helped to determine which class of IP address being used. There are 5 classes altogether. Firstly is class A. It has a default mask of 8 bits, ranging from 0 to 127, and are used to assign to network with large number of hosts. By looking at the above example, we can see that the first octet consists of network and the remaining octet is made up of hosts. Moving on to class B, it has a default mask of 16 bits, ranging from 128 to 191, and are used to assign to large size network. Referred to the above example, we can conclude that the first and second octet are made up of network, and the remaining octet are made up of hosts. Class C has a default mask of 24 bits, which ranging from 192 to 223 and are used to assign to small network. Class D, meanwhile, are ranging from 224 to 239, which are reserved for IPv4 multiclass addressing. And the last class is Class E, which ranging from 240 to 255 and are reserved for experimental use.
And basically, it is simple as that. Wow, it's really interesting.
Oh,
Okay, now you all can set your own IP address.
Wow.
now you understand what the topic? I think let's move to next topic. You Ashraf. Hey, no time no see, you know?
I'm busy right now.
No. You know that we have presentation tomorrow?
Of course, I know.
What's your topic, ah?
My topic is NNT.
Oh, what's that?
And I will explain you about NNT from A to Z.
Oh.
What is NAT? NAT is Network Addressing Translation, and we supply it to NAT. So what is purpose? This is the process where a network device, usually a firewall, assigns a public of address to a computer or group of computers inside the private network. So which means inside the network there are two networks, which is private network and public network. The private network cannot be known by the outside network. And also two purposes to limit the number of public IP addresses in an organization or company. And another important thing is the purpose is to for security purpose. How NAT works? Let's say Sam are playing his laptop and want to ask information, and his IP address for laptop is 192.168.168.29.1, which is .1 is the number of ports that have been used by Sam. Also in his house, his mother want to receive an email from another server. Let's say his mother has IP address 192.198.29.2. Those two IP addresses is a private network, and both of them are using router to connect the internet. Let's say the router have IP address 22.34.54.11, which is the router has a public address. And also you need to have a network send data, web server router, and also the web server which you want to send the information through it. Let's say the web server have IP address 22.22.22.20.22. Sorry, there is a mistake here. Okay, how does it work? Let's say Sam want to ask to receive information. Let's say he want to ask what is temperature in his house now. So from the private address, actually it can't be sent through the web server address 3 because this is a private network which is it cannot be discoverable. And then how the web server want to send information if it doesn't know where to send it? Okay, this is the story. From the private address, we gonna send this to the router. So the router is displayed as a source NAT, which is begin the translation of the address. Instead of it, there is a data. When someone want to send data, it will go straight to the router, and it assigns a public address which can be known by the other network. So the router will go straight to the web server address, which is 22.22.22.22, and the web server know where it comes from and where it need to send back. After we start to send information, and we also receive information, that how it progress. So from the let's say the 22.22.22.22.8, this is where the information received. This is 80 is port number of the web server address. Goes to the source NAT game, which is goes to router 44.50.42.11.9.1, which is the same is connected for the port 1. And after the source net begin game, the SAM successfully received the data as the source net send data through his private address, which is 192.198.29.1. In other scenario, let's say house mother will receive the email from the web server. Let's say the web server address has a number 22.22.22.22.45 is port number for the web server address, and it's different from the other one because his mother is receive information from another port of the web server address. Let's say the information is straight to the source NAT so 44.23.22.11.2, which is .2 is the number of port using by Sam's mother after the translation has been successfully done. It will goes to the private address of his mother 192.168.29.2. Then his mother received an email successfully. But remember, the private network cannot go straight to the web server address because it can be known by the web server address. But the thing that how it works is we need to have the source NAT.
And that's all you need to know about NFT.
Oh, NFT. Oh, interesting.
Yes.
Hey, have you understand about the topic? I think there's more of this topic.
Hey, what's wrong with you?
I don't understand about classes everything at all.
What topic is that?
Classes everything.
Oh, class left.
Yeah.
Okay, let me explain.
Okay, now I'm going to explain to you guys about IPv4 classless, or else we call as CIDR. So let's restart. Actually, classless network is known as CIDR. What is CIDR? CIDR is classless inter-domain routing. CIDR, also called as supernetting. CIDR is a new concept to manage IP networks. Recently, the size of global routing tables have grown very fast, so it can cause routers to become saturated. Hence, CIDR was created to reduce the sizes of routing tables. So no more concept of class A, B, nor C network in CIDR. Like a class C address in classful networking, 8/24 would indicate that 24 bits are used to identify the network and the remaining 8 bits are used to identify the host. Unlike classful networking, CIDR provides much more flexibility than 8, 16, and 24-bit network mask. Under CIDR, the number of bits used to indicate the network portion of the address can be from /8 to /30, although more commonly only /13 to /20. Okay guys, now I'm going to explain about how does CIDR work. An IP address is represented by a prefix, which is the IP address of the network. CIDR networks are identified with a trailing slash followed by a number M. What is a number M? A number M is a number of leftmost contiguous bits to be used for the network mask. For example, the IP address 144.16.192.56/18 The /18 at the back is what we call as number M, which is represent the network portion. Since CIDR address space can overlap byte boundaries, the method to tell which address is a part of which network is a little bit trickier than with classful networking. Everything that needs to be known is indicated the /number, however. Okay, now I'm going to explain about rule of CIDR. One of the rules of the CIDR is the number of addresses in each block must be a power of 2. The beginning address in each block must be divisible by the number of addresses in the block. For instance, a block that contains 16 addresses cannot have beginning address as 144.16.223.36, but the address must be 144.16.192.64 is possible. Let me show you an example of CIDR. Given a network address 172.16.0.0/21, it is known that the first 21 bits of that address represent the network portion. That leaves 11 bits for host information, about 2,000 host addresses. To easier see what that range looks like, convert 172.16.0.0 into binary. In binary, this the number will look like. As you can see, the bold number or the blue color number show the /21 network mask. No modification can be done to network portion of the address. The remaining 11 bits are available for host assignment on the network. After the bold section, the remaining 3 bits in the third octet can be added up for a maximum value of decimal 7, which is 2 to the power of 2 plus 2 to the power of 1 plus 2 to the power of 0. All of the bits in the last octet are available, and when converted to decimal, it is equal to 255. With all the bits turned on all 1, the decimal number turns out to be 172.16.7.255. This is the end range of the 172.16/21 network. 172.16.0.0-172.16.7.255, which is 172.16.0.0 to 172.16.7.2. And now we're moving on to CIDR subnet mask. Basically, the CIDR subnet mask is the process to determine the subnet mask for a CIDR address with the number of bits in the network portion of the address are converted to 1 and right padded with 0 until there are 32 numbers, and then divided sequence of numbers into 4 octets. Then convert the 4 octets from binary to decimal. Now, what you can see here is what we call CIDR notation, which there are binary masks at the left side, and at the middle is what we call prefix length, which we got 32 prefix length over there, and a subnet mask as well. So yeah, this is what we have in IPv4 classless, or what we call as CIDR. So I hope that you get some ideas from what I have explained to you. Thank you.
Hello guys, my name is Iqbal Hanif. I'm from ICT, first year, second sem. Now me and my group, we are doing our project or presentation for data communication network on IP addressing and routing. We're moving on to routing. What is routing? Most users refer to routing as the Wi-Fi for the internet, as the router. But routing actually means moving a packet of data from a source to a destination. Or it is also known as process of selecting a path for traffic in the network or between or across multiple networks. So routing involves in not just only one single traffic, but involves in between or across multiple networks. So routing is basically a big hardware device. Now routing is usually performed by a dedicated device called a router, where usually users refer to router as their Wi-Fi router. But router is not just that. It is also something else. Routing is also a key feature of the internet and is also performed for many types of networks. What I meant by networks is routing perform many types of networks, including circuit switch networks such as the public switch telephone network, PSTN, computer networks such as the internet, as well as in networks used in public and private transportation, such as the systems of streets, roads and highways in national infrastructure. Moving on, why I said routing is the key feature of the internet. Why? Because it enables messages to pass from one computer to another, and eventually it will reach the target machine. Part of this process by sending a message from one computer to another involves in analyzing a routing table. So routing, when passing a message from one computer to another computer, it creates a routing table to determine the best path. Moreover, routing by users are usually confused with bridging, in which bridging performs a similar function like routing. Why bridging? Bridging occurs at a lower level, and it's more of a hardware function, while routing occurs at a higher level and it performs complex analysis. Why does routing perform complex analysis? Is to determine the optimal path for the packet. Moving onwards, routing, there are two types of routings. First type of routing is static routing, and the other one is dynamic routing. What's the difference between static and dynamic? Static routing learns from the administrator and adds all network location manually, and also must update after changes. And for dynamic routing learns from the neighboring router through protocols and adds network automatically, and also changes are auto updated. Now let me explain briefly on static routing. Static routing is the process in which the system network administrator would manually configure network routers with all the information necessary for successful packet forwarding. Now I'm going to explain deeply about static routing. What is static routing? Now I'm going to explain the advantages and disadvantages of static routing. The advantages of static routing: it's an easy implementation, secure routing, no overhead, and its predictability. What I meant by predictability, what is it? If I change my network design and layout and suffer from a device failure, the static routes do not change. It will always know the path your data will take. Easy implementation. This issue is relatively depends on your size of your network. Although the small networks are easy to implement, but as the network grows, it applies changes to all the routers and can become a big task. That's why through routing it is very easy to implement. Next, it is a secure way of routing. Why is it a secure way? Because there will be no information that is shared with other routers, so the information is kept between to only the router the message received. It puts on no overhead on resources such as CPU or memory. Why? Because static routing has zero overhead, whereas all dynamic routing protocols have some degree of overhead. For example, a network with 200 segments, the router will send updates from each interface every 30 seconds, and those updates are about 3 kilobytes of data. So over a course of day, this traffic adds up, which slows down. And that's all for the advantages of static routing. Now we're moving on to the disadvantages of static routing. First of all, the disadvantages of static routing is suitable for small network. If a link fails, it cannot reroute the traffic, which causes a disadvantage for a static routing. And it's lack of scalability and the redundancy. Why? If a link fails and it cannot reroute the traffic, why? Because it must be done manually by the administrator. Next, lack of scalability. Why? For example, the 200 segment network mentioned earlier, it can be 100 routers or 50 routers, which will be dealing thousands of routing table entries. So it will be hard for the static routing. Why? Because static routing calculates manually and doesn't calculate automatically. So that's why it lacks of scalability, in which static routing has to keep up to date with every routing table entries because of its manual input. Moving onwards, what I meant by no redundancy for static routing is that when the static routes contains a failover or redundant path, we must manually adjust the routes to move data through an alternative path, in which causes trouble and waste time for any user. So a static route cannot be updated automatically, but we have to update it manually. These are all the advantages and disadvantages of a static routing. Moving forward, we have dynamic routing, and the advantages and disadvantages of dynamic routing. First, which is the advantages. Advantages of a dynamic routine are it is suitable for all network, automatically build route tables, reroute traffic if any link fails. Why I say dynamic routing is suitable for all network? Why? Because, for example, static routing, for example, for static routing, it can handle only a certain amount of networks, in which the administrator or the user has to update it if a new network or the old network is being changed. But for dynamic routing, it can handle all networks. It is suitable for all networks, and when a network is updated or changed or added, the router will auto update it automatically. So it is an advantage to dynamic routing. Next, automatically build route tables. When a network is being added or changed, it will automatically build route tables. Other than static routing, it won't build any route tables automatically. You have to manually build it. But for dynamic, it automatically builds a route table for every network added or changed. For moving forward, reroute traffic if link fails. Why I say dynamic routing is better than static routing? One of its advantages are it will automatically reroute if a link fails. It is less work for an administrator because it is automatically rerouting the failed links, in which is an advantage for the administrator. And furthermore, it gives greater uptime for users because the routing protocol has intelligence and can react faster. And also it has more automation, in which does not have in a static routing. For dynamic, it's more on automation. So whenever a link or a route or a network is changed or updated, it will automatically update it by itself, and relates to the less work for an administrator because of its automation. Now I'll explain to you about the disadvantages of a dynamic routing. First of all, what the disadvantages of dynamic routing is. It is very hard to implement. Why? Because of its complexity, in which gives a hard time for an administrator to implement it. Next, it gives a less secure routing device because of its complexity and because of its access to a lot and a number of different kinds of routers, which gives it a very less secure network. Furthermore, it adds additional overhead, in which causes your CPU or memory to run at a slow rate. And that's all for disadvantages of a dynamic routing. Next, although dynamic and static routing has its pros and cons, we can use either static or dynamic because it's good for its certain kind of job scope in need. For a static, it has its pros, and for a dynamic, it has pros at an appropriate time or an appropriate place. So therefore, a dynamic and a static routing is very important.